So today I'm going to be controlling this DC motor with the push button, the 55 timer chip, and the transistor. So when I press this button, if I press it again, it's going to turn on. So basically what's happening here is that the push button, right? To control the push button, we have to connect one side of the push button to ground and the other side to pin 2 of our 55 timer. So the pin 2 of our 55 timer is the trigger pin, and then we're connecting one side of the push button to pin 2, which is our trigger pin. So the pin 3 is actually our output. So the pin 3 is being connected to the gate of our transistor. So our transistor has 3 pins, which are the gate, the drain, and the source. So the pin 3, that's our output of our 55 timer, is connected to the gate, so which is pin 1, which is pin 1 of, that's it, this pin 1, that's the first side, the pin 1 of the transistor. So then the middle pin, that's the center pin, is going to, which is the drain of this transistor. The pin 2 is going to either your LED or the DC motor. So now the pin 2 is going to, pin 2 of our transistor is going to the DC motor, and then the pin 3 is going to ground, so which is the source, that's this last pin here, it's going to ground. So now for the middle pin, which is the drain of this transistor, we're actually connecting the negative part of our output, that's either the DC motor or your LED. So it's actually the negative pin that is being connected to this transistor, and then the positive pin, if you check this wire, the positive pin is connected to the positive side of our breadboard. So that's how this stuff works. So in all of this, what I've learned from this project is that this transistor, this MOSFET transistor, is actually more reliable than this transistor. So I think this transistor is the what's it called again, the S80, it's S8050. So when I tried using it, it wasn't powering my DC motor, but when I switched to this transistor, it got better. So I think it's more preferable to use this transistor than this.